Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss graphing systems of equations. So what is a system of equation? A system of a linear equation is a set of two or more linear equations. So a system of linear equations is a set of two or more linear equations. And a solution of a system of linear equations is a coordinate that satisfies both equations at the same time. So a solution of a system of linear equations is a coordinate that satisfies both equations at the same time. The point of intersection is the same thing as the solution of the system. Sometimes our solutions are going to be no solution. So when we have no solution, that means the lines do not have a common point of intersection. Therefore, the lines are parallel. So when there's no solution, we're graphing a system of equations. That means the lines do not have a common intersection. Therefore, the lines are parallel. A system of equations has infinitely many solutions when the equations are exactly the same. They are equal. So a system of equations has infinitely many solutions when the equations are exactly the same. The equations are equal. So let's look at some examples of different kinds of system of equations. So after reviewing key points and vocabulary on graphing system of equations, let's look at the diagrams below. Our first diagram to the left has different slopes. And if you notice, the lines intersect. So when the lines intersect, there is one solution. So when the lines intersect, when there are different slopes, there is only one solution. And the solution is where they intersect, the point they intersect. So this point right here is the solution, where the lines intersect. And that would be point 1, 2. That is your solution. And we're going to do some examples together on that in a few. Let's look at the one in the middle, the graph in the middle. It has the same slope, different y-intercepts. When the slopes are the same, the lines are parallel, so there are no solutions. So when you have the same slope but different y-intercepts, the lines are parallel, so there are no solutions. They don't intersect, there's no solution here. Let's look at the graph to the right. This is the same slopes, same y-intercept here. So when the lines are equal, there are infinitely many solutions. So when the lines are equal to each other, when they have the same slope and same y-intercept, there are infinitely many solutions. So now let's do some examples together on how to graph a system of equations. So let's look at example 1. Let's read our directions. We want to solve by graphing. And this is a system of equations with no solution. And we have y equals 3x plus 2 and y equals 3x minus 2. Well, first, what do you notice about both of these equations? What do we notice here? They're both in slope-intercept form, y equals mx plus b. Okay, they're both in y equals mx plus b. So we have to identify our slope and y-intercept using slope-intercept form. As you recall, our m is our slope, and our b is our y-intercept. So our m is our slope, and our b is our y-intercept. And we are going to graph each equation separately using the slope-intercept form. So let's look at our first equation, y equals 3x plus 2. And we're going to identify our m. Our slope is equal to 3. And whenever you have a whole number, you want to put it over 1. And our b is 2 plus 2. So b equals 2. So let's graph that. We want to graph our b first. So b is 2, so 0, 2. And then you're rising over your run. You're going to rise 3, 1, 2, 3. And you're going to run 1 to the right because it is a positive slope. Now when we're doing system of equations, we want to do a couple points. So now let's go down 3, 1, 2, 3, and go 1 to the left. You're going to make your line and label it y equals 3x plus 2. So now we just graphed our first line. Now let's graph our second line. Let's identify what our m and our b is in our equation, y equals 3x minus 2. So your m here is 3. So we have 3. You'll put that over 1 because you want your rise over your run. And then our b is equal to negative 2. So now let's graph that. B is negative 2. You're going to go down 2. 0, 2 is your coordinate. And now we're going to rise up 3. 1, 2, 3. And over to the right 1 because it's a positive slope. Let's do that again. Up 3. 1, 2, 3. And to the right 1. The positive slope. If you go down 3, 1, 2, 3, you're going to go to the left 1. So you're going to make your line and label your line y equals 3x minus 2. So now what do we notice here? We notice the lines are parallel. They're not touching, they're not intersecting. So whenever your lines are parallel, your answer is no solution. So there is no solution to these two systems of equations. Another way to identify if there's no solution is whenever we have the same slope. So notice our slope is the same. Whenever we have the same slope, the lines are always parallel and it's always going to be no solution as your answer. So whenever we have the same slope, it's going to be equals parallel lines, which equals no solution. Now let's look at an example with infinitely many solutions. So in example 2, it says y equals negative 3/4 x plus 3. And then it also says y equals negative 3/4 x plus 3. So let's identify our m and our b for each equation. Our m in the first equation is negative 3/4. And our b is 3, positive 3. So now let's graph that. We're going to go up 3, and it's a negative slope, so we're going to rise 1, 2, 3, and go to the left 1, 2, 3, 4. You want to make a couple points, so you want to go down 3, 1, 2, 3, and out to the right 1, 2, 3, 4. And now draw your line, connect your dots, and label your equation y equals negative 3/4 x plus 3. Now let's look at our next line. Y equals negative 3/4 x plus 3. Again, our m is equal to negative 3/4, and our b is equal to 3. So let's graph that. Your b up 3, and then your slope, you're going up 1, 2, 3 over 1, 2, 3, 4. Your dot, and then you're going to go down 1, 2, 3, and to the right 1, 2, 3, 4. Draw your line, and if you notice here, it's the same line. So whenever we have the same line, your answer is infinitely many solutions. So our answer here is infinitely many solutions. And we have infinitely many solutions when our slopes are the same and our b's are the same. The equations are the same. So when you have the same slope and y-intercept, it is the same line. Therefore, your answer is infinitely many solutions. Now let's look at examples where there is an intersection with the two equations. So we just did two examples of system of equations with graphing when an answer was no solutions or infinitely many solutions. Now let's do an example where there is a numerical answer. So we have a system of equations below, And it says y equals negative 2x plus 2 and y equals 3x plus 2. So our first step, again, we're using y equals mx plus b to identify our m, our slope, and our b as our intercept. So when y equals negative 2x plus 2, our slope is equal to negative 2. So m is equal to negative 2. We put that over 1. And then our b is equal to 2. So we're going to graph that. 0, 2, our b value. And our slope is negative 2 over 1. So you're going to rise 2, 1, 2, and you're going to the left 1 because of the negative slope. Okay, again, you want to go up 1, 2, and to the left 1. You want to make multiple coordinates, multiple points here. Let's also go down 1, 2 over 1. And let's go down one more, 1, 2 over 1. Now we're going to draw our line. And you want to label it y equals negative 2x plus 2. Now let's graph our next line. Y equals 3x plus 2. So our m is equal to 3. You want to put that over 1. And our b is equal to 2. So let's graph it. Our coordinate 0, 2. And if you notice, we just overlapped at that point. Let's continue to graph it. We're going to go up 3, 1, 2, 3, and to the right 1. And you're going to go down 3, 1, 2, 3, and to the left 1. Make your line and label it y equals 3x plus 2. So now our answer to this problem is the point they intersect at, which is right there. That's the point they intersect at. Therefore, our answer is the coordinate that satisfies both of these equations here is coordinate 0, 2. So your point of intersection is your answer. So your point of intersection is your answer, 0, 2. That means when x is equal to 0 and you substitute it in the problem, your y is going to be equal to 2. And this coordinate satisfies both of those equations. Let's do another example. So example 2, it says y equals negative 1/2 x minus 1 and y equals x minus 4. So let's first identify our m and our b in our first equation. Y equals negative 1/2 x minus 1. So my m is equal to negative 1/2. And my b is equal to negative 1. So let's graph that. Our b is negative 1. And now you have to rise 1 and run 2 to the left because it's a negative slope. Again, you want to make multiple points when you're using system of equations. Rise 1 and to the left 2. Okay, let's go back to our b and we're going to go down 1 and to the right 2 and make our coordinate. Let's do one more, down 1 and to the right 2. Now let's draw our line. And you want to label your line y equals negative 1/2 x minus 1. All right, let's go to our next equation. Y equals x minus 4. And remember, there's a 1 in front of that x, so your m is equal to 1 over 1. And then our b is negative 4. So let's graph that. You're going to go down 4, and then you're going to rise up 1 and to the right 1. Again, up 1 and to the right 1. And once you hit a point, you can stop there. So we can make our line and label it y equals x minus 4. And then our point of intersection is our answer. So your answer is 2, negative 2. And that coordinate is a solution for both equations. So now what I would like you to do is the U-try section. Please complete problems 1 and 2, and we will discuss it in class. Thank you.